This is a graph of the global average temperature in the world. And it shows that it was low in the end of the 19th century and rising steadily, rising in the 20th century. But it hasn't been rising steadily. It's gone up and then stayed flat and then gone up fast. And so even though carbon dioxide has been going up during this whole period. So how can we explain this temperature change? By the way, this is in degrees Celsius, so you multiply by about 2 for degrees Fahrenheit. It also shows that 2005 was probably the warmest year for the past 125 years. And if you look at other data, it was probably the warmest year for the past 2,000 years. In the beginning, there were a lot of volcanic eruptions here, and most of this warming was natural, although a little bit of it was caused by greenhouse gases. After World War II, when industry started, there was a lot of pollution of the atmosphere, and it blocked out the sun and caused cooling, and that counteracted the effects of these carbon dioxide and other gases that warmed the planet. But after the EPA was formed and other places around the world cleaned up their act, now the temperature has been rising steadily for the past 30 years, and the effect of the greenhouse gases really dominates. And this is the last couple years. I got these data on Monday, so this is the latest as of September 10th. Amount of CO2 in the atmosphere, about 380 parts per million. What you can see is that there's a seasonal cycle. It goes up during the winter, and in the spring it starts to go down all summer long, and then it goes up in the winter and down like that. But superimposed on that, there's this upward trend. Does anybody know what causes this seasonal cycle? Trees. Trees are part of it, so forests are part of it. In the summer, in the spring, when the trees start making leaves and branches and flowers, those are made out of carbon. Photosynthesis takes it out of the atmosphere and sucks it out, and the CO2 concentration goes down. As it decomposes in the winter, it goes back up. But in addition, humans are putting CO2 in, and some of that stays in the atmosphere, so on top of that, there's this upward trend. Earlier this year, it was 387 parts per million. That's the highest it's been in the last 20 million years. Where does the CO2 go that we put in? Well, about 40% of the CO2 that we put in by burning coal and oil and chopping trees down goes into the atmosphere. About 60% of it comes out every year. About half of that gets dissolved in the water, and about half of that goes to land cover, to growing more vegetation, more trees. So this carbon sink, if this didn't happen, the CO2 would be going up much faster, and climate would be changing much faster. One of the issues is are these ratios going to change in the future, or are they going to stay the same? And it looks like the ocean is becoming more saturated and will absorb less CO2. I mean, you all know, if you have a can of Coke, does it hold its fizz more when it's cold or when it's warm? When it's cold. So that's carbon dioxide dissolved in the I gave this talk in France once. They said, oh, we say Perrier here. We don't say Coke. So as the oceans warm, their ability to hold CO2 will go down, and more will remain in the atmosphere. We don't really know it very well, but it looks like forests also become kind of saturated, and their ability to take CO2 out, their ability to continue to grow, also goes down. So how do forests affect climate? Well, growing forests sequester carbon. Obviously, if there wasn't a forest there, and now there is, all those trees are made out of carbon. So the carbon that makes the trees was taken out of the atmosphere. So that takes it out of the atmosphere. A mature forest, which isn't growing, which is stable, very slowly sequesters carbon. The only way it can sequester carbon is if the forest litter at the bottom that falls down eventually builds up, and that goes down into the ground. That's where our coal and oil came from in the first place, but that's a very slow process. Carbon fertilization is increasing forest growth by making the trees grow bigger with more CO2. In fact, when people have greenhouses, they pump CO2 in to make the crops grow faster. So one of the ways of using CO2, taking it out of, they're doing it, I think, in the Netherlands to grow tulips, is they take it out of the, Shell Oil takes it out of the stack when they burn oil and put it in greenhouses and grow more tulips. So, but A recent paper shows that climate change is slowing the growth of tropical forests. So because it's getting warmer and drier in the tropics, the forests don't grow as much in spite of the excess fertilization. That's counteracting some of that. Now, trees also evaporate more. They pump a lot more water into the atmosphere, and that cools the surface, and so that's also something good for the climate. They also, this water that goes in the atmosphere increases cloud cover, and that rains more, and that also produces cooling and reflects more sunlight. So all the things in blue are things that are good for the climate, but the thing in red is that it produces warming by being darker. So what do we do about it? I'm summarizing a very detailed talk or even a semester course in this, so I'll just give my opinion. I don't think global warming is good. I think humans are causing it, and we have to do something about it and slow it down as much as we can. So some of the suggestions are to use energy more efficiently, hybrid autos, trucks, solid-state lighting instead of these incandescent bulbs like we have here, more efficient furnaces and appliances, and then conservation. Better insulation, better public transportation, bicycles just don't use as much. When we do use it efficiently. Use renewable energy, use solar and wind energy, geothermal energy, biomass. And then carbon sequestration. If you burn coal, you should trap the carbon dioxide and pump it back underground or underwater and not let it go into the atmosphere. We know how to do that. It's already being done to pump into oil wells to get more oil out. That's not what I think we should do with it, but we can put it in and not let it back in the atmosphere. It costs more to do it that way, but it's possible to do it. And if you use biofuels, you grow crops, you burn it, and then you sequester it. That'll be a net sink. If you do it for CO2, at least it won't get into the atmosphere.